An aerial ladder, or a self-supported, turntable-mounted, power-operated ladder on top of a fire apparatus, meets NFPA standard 1901. This aerial ladder is a continuous egress route from an elevated position to the ground. A 24-foot extension ladder consists of two sections. The first section being the base or the bed section, which is the lowest or widest section of an extension ladder. This section meets NFPA standards 1931. The bed section also has butt spurs, which is a component of the ground ladder that supports the remains of the ladder in contact with the lowest support surface to reduce slippage. The second section of the ladder is the fly section, which is the extended section of the two portions of the ladder. The fly section meets NFPA standard 1901 and is any section of an aerial telescoping device beyond the base section. Another component of a 24-foot extension ladder, or any ladder in general, would be the beam, which meets NFPA standard 1931. The beam is the main structural side of a ground ladder. Another part of the ladder would be the guides, which are a strip of metal that serve to guide the fly section during extension. Another part of the ladder, which is very important to safety, would be the heat sensor label, which meets NFPA standard 1931. The heat sensor label changes colors when exposed to certain temperature, thus indicating that the ladder should be put out of service. An I-beam is a ladder beam constructed of one continuous piece of eye-shaped metal or fiberglass to which the rungs are attached, which is a different but similar form to a beam. The next part of a 24-foot extension ladder would be the dogs or the pawls, which meet NFPA standard 1931. The pawls are the devices attached to a fly section to engage ladder rungs near the beams of the section for the purpose of anchoring the fly section to ensure that the fly section is stable and locked in. Protection plates are a reinforcing material placed on a ladder at chafing and contact points of the ladder to prevent wear. A rail is the top or bottom piece of a truss beam assembly used in the construction of a trussed ladder. On a particular ladder, known as a roof ladder, which is a single ladder equipped with hooks at the top of the ladder, which meets NFPA standard 1931. Roof hooks are the spring-loaded, retractable, curved metal pieces that allow for the tip of a ladder to be secured to the peak of a pitched roof. The staples will be included in the next section of the video. Another ladder in the fire service would be a 35-foot wood extension ladder. One component of a wood ladder would be a tie rod. A tie rod is a metal rod that runs from one beam of the ladder to the other to keep the beams from separating. Tie rods are typically found in wooden ladders. The 35-foot ladder took many years of reaching perfection. Companies such as LALCO or Lalco or Alico, ALACO, had huge contributions to the advancement of the wooden extension ladder. The tapered trusses were made to be lighter and more stiff specifically for efficiency and safety. The tapered trusses are made out of Douglas fir, which has been proven to be the most durable and strongest for a wooden ladder. Longer length wooden extension ladders are made from 100 to 200-year-old Douglas fir trees from Willamette Valley, Oregon. The swelled center rung technology allows for lighter yet still incredibly durable rungs. These rungs are made out of hickory, each fitted and glued with PVA, which is known as polyvinyl acetate glue. Guides, crossbeams, and miscellaneous parts are made out of red oak. These Alico wooden ground ladders stay strong versus fire, and they do not conduct heat, and they do not conduct electricity. A banger ladder is a ladder equipped with tormentor poles or staples that stabilize the ladder during raising or lowering of the ladder. Staples meet NFPA standard 1931. These poles are attached to each beam of the base section, which assist in raising the ladder and help provide for stability of the raise of the ladder. A single section ladder, known as a straight ladder, is a fixed length ladder, and it may also be called a wall ladder or a single ladder. It is commonly 12 to 14 feet long, but can be up to 20 feet long. This single section ladder weighs a lot less than a two-section ladder for obvious reasons. Another ladder in the fire service is known as a combination ladder or a chief's ladder. A combination ladder can be converted from a straight ladder to a step ladder configuration, or as depicted in this photo, an A-frame. Such ladders are convenient for indoor use and for maneuvering in tight spaces. They are generally 6 to 10 feet in length in the A-frame configuration and 10 to 15 feet in length in the extended configuration. Another ladder in the fire service is called a folding ladder. A folding ladder, or also known as an attic ladder, is a narrow, collapsible ladder that is designed to allow access to attic holes and confined areas. The two beams fold in to enhance the ladder's portability. Folding ladders are commonly available from anywhere from 8 to 14 feet. Generally, these ladders are 10 to 14 feet. It has no halyard and it is manually adjusted to open and close the base section. Another ladder in the fire service is known as a Fresno ladder. A Fresno ladder is a narrow, two-section extension ladder that is designed to provide for attic access in the situation of a structural fire, in which a 24-foot extension ladder or a 14-foot straight ladder would not be able to gain access to. The Fresno ladder is anywhere from 10 to 14 feet. It has no halyard and is extended manually. Also, a Fresno ladder can be used in tight space applications such as bridging over a damaged section of an interior stairway. Any ladder in the fire service must be visually inspected at least monthly. A ladder should also be inspected after each use, and a general visual inspection should at a minimum adjust the following: beams, rungs, halyard, halyard extensions, ladder slides, pawls, butt spurs, heat sensors, bolts and rivets, welds, roof hooks, metal surfaces, fiberglass and wood surfaces, and any section of the ladder that is typically known to have abrasion. All firefighters should be able to perform routine ladder maintenance. Maintenance is simply the regular process of keeping the ladder in proper operating condition. Ladder inspection is very important because safety is always number one. The importance of having proper working ladders is a must due to the fact that ladders are one of the most basic and one of the most mandatory tools of the fire service. Without ladders, ventilation may not be possible. So, the maintenance of a ladder is vital. When talking about the fire service and ladders, one vital section to ladders is ladder commands. Each firefighter must know the proper ladder commands. However, each station may have their own ladder commands, which are similar to the basis of the ladder commands, but could be revised just slightly. So here we go. High shoulder carry facing the butt. Beam ladder. Thus, moving close to the tip of the ladder, then stating lift ladder, which is a series of propping or pushing or propping the ladder up over your head with both hands on the beams and moving yourself closer to the center of the ladder, thus stating shoulder ladder, which is followed by a squat, if you will, which is exactly how you get to the state of which this firefighter is in this depicted photo. Then you must state forward ladder, which lets everybody else on the fire ground know that there is a ladder coming through and to be cautious. So, ladder coming through, and another key part to ladder commands is always making sure overhead all clear or clear behind. This is important because most ladders in the fire service are made of T6 alloy aluminum, which is a conductor of electricity. And in case of low hanging electrical wires, this is highly dangerous. Therefore, you must always state clear above. Then you state butt to ground, and the ladder is pushed into the building. It is then leveled off, and then rung to rung, pushing the ladder forward into the building. Once the ladder is completely parallel and touching the wall of the structure, you must state ladder high. And ladder high is important on the fire ground as well because this signifies that there's a ladder straight up, and everybody on the fire ground must be cautious about a potential, God forbid, a potential fall of the ladder, which could in return hurt somebody on the fire ground. So, once the ladder's high, you must state adjust ladder. So, you adjust the ladder, stick the ladder into the ground, and one thing to remember is that the ladder degree must be 3/4 the working length of the ladder, or 70 to 75 degrees, which is the proper climbing angle. Also, you must make sure that there are 4 points of contact, because if there is not, that is a safety hazard. Once the ladder is properly put into place and is able to be climbed, and in this case must be taken down, you must state clear above. This is to make sure that, well, there are no low-hanging wires, but that there are no firefighters on the top of the ladder that could possibly jeopardize their life if you were to adjust the ladder. So you must say clear above. Once you have cleared above, you go ahead, you say adjust ladder, then you stick the ladder parallel to the building, touching the structure. Then you must clear behind. Clear behind is also important because you must make sure that you will not hit anybody behind you. This is a safety violation and a safety rule you must always follow. So, clear behind. Then you lower the ladder, one rung after another. And then this is a little bit tricky to say over video, but you cross your hand over through the rungs and you grab the ladder, which is thus able to properly stabilize itself on just using one hand. So you say forward ladder, ladder coming through, ladder coming around, stop ladder, beam ladder, and then ground ladder. This was a step-by-step audio version of how to properly do a one-person high shoulder carry. This video was made by the Fire Academy of William S. Hart Fire Academy by the group of Galvez, Haggins, and Beverly. This is the latter portion of the second semester project. Thank you for listening.
Alright, so firefighting PPE. PPE stands for personal protective equipment. It's a necessity in the fire service, and it's mandatory for whenever you respond to a structural fire call, or just any call that involves fire, such as possibly a car that's on fire on the freeway or whatever have you. We have the bunker coat, or also known as the turnout coat. Consists of 3 layers, and it just buttons up, and you have a little notches here. It varies from coat to coat. We have pockets here that you could put maybe a hand light, flashlight. We could put possibly a thermal imaging device in one of your pockets. We have little latches here that you could put more accessories on. And let's see, turnout pants or bunker pants. Consists of an outside and a inside layer. Has 3 layers as well, and they're attached via buttons. So you have your firefighting boots, which are steel toe and steel shank, to prevent any injury from either heat, or if you accidentally drop a tool on your foot, nothing will go wrong, because that steel toe prevents any metal from possibly crushing your feet. And can't forget your helmet and eyewear. Eyewear is very important. And there's also another component known as the fire hood, but I don't have that. And yeah.
Alright, this right here is your wildland PPE. It's much thinner than your structural, only 1 layer. Here are your gloves. Always want to make sure you have your gloves while doing anything in the fire service. Here are your pants. Only a couple pockets on here. You can put tools in here. There's a protection for your neck right here, so your neck doesn't burn up. You're gonna want to wear this during any wildland fire or anything. And that's it basically. And you want to make sure you're wearing steel-toed boots. That's it. Oh, and here's your helmet right here. Always make sure you have your helmet, goggles. Make sure anything doesn't get in your eyes. Safety first.
Alright, so underneath our turnout gear, we must wear properly approved clothing. This is not properly approved clothing, but in our junior academy, we're always made to wear PT clothes underneath, just to make the donning process easier. We have our PT shorts. It has our academy on it. Each is starts with first initial, last name, and our academy name. Same thing goes with the top, and that's our PT clothes.
firefighter must always be able to don his structural gear within 1 minute, because you have 5 minutes to get into the scene, so time is always a necessity. Here are your safety goggles right here. They're obviously not NFPA approved. The lens is made out of plastic, solid plastic. The brand is DeWalt. And you just want to make sure you have your goggles on in any situation that can be hazardous to your eyes. Safety is always first. And here are your straps to adjust.
Alright, so here we have our boots for structural firefighting, and we have our turnout pants. 3 layers, of course. Have your outside shell. You have your moisture barrier and your thermal barrier. This one is actually assembled by some buttons that go together that keep the 2 different sections together. Here we have our straps that go over our shoulder, just to keep the pants up. There's some latches that would help you change the width of the pants. Our straps are mounted onto little buttons here. There's 4 of them. And let's see, right here, this is it's to adjust your width again. And let's see, you have some pockets that could fit some tools or whatever you need. And down here you have some little buttons to adjust the opening of the bottom end of the pants. You have a zipper here that also helps you put on your turnout. Same with this side. We have the pants like this because in case of a fire call, you need to quickly put on your PPE, and this is just one way to easily get it on. See inside here of the boots, you have your little manufacturer's guide, just a little information about the boots company. And here on the pants, this is the Morning Pride. That's the company. It says first in safety, quality, performance, and innovation. And inside here you have your manufacturer's guide, but like I said earlier, it's old and worn out, so you can't really read it. But on a newer pair of turnout pants, you would you'd follow these guidelines to clean or dry your turnout pants or coat. So here we have a Wildland turnout coat. This one is also different from structural firefighting turnout coats. This one only consists of 1 layer, as you can see. Here we have flame resistant cotton fabric, which would be Nomex. It says durable, flame resistant, and gives you a little instruction on how to properly clean your turnout gear. So we have our little protective extension of the coat to go around your neck. We have a strap, so you could strap it together like that, and you have pockets in the front as well. More pockets. You could fit maybe
a scrunch in here if you're a sawyer. You could fit possibly some hose clamps to clamp the hose if you're on a hose lay team. Let's see. So yeah, the reason being for the one layer on wildland gear is because there's a lot of hiking, and there's a lot of laborious adventures that you have to go on, and if you have 3 layers, that would just be too hot. You have your gloves here. These are obviously not NFPA approved, but there are specific gloves for wildland firefighting, and there you have it. All right, so here we have the inside of our turnout coat. Like I said earlier, it consists of 3 layers. You have your outside shell, you have your moisture barrier, and you have your thermal barrier. Moisture barrier keeps out any steam or any water from engine crew, attacking the fire. Steam is it's a fuel, so you definitely don't want that getting into your turnout gear. Let's see, we have mini buttons that are the main assembler for the turnout coat. So you have your little notch here, so you could hang it up in the fire station. You have your manufacturer's guide. This one's a little old and you can't read it, but this would tell you everything that you need to know for cleaning, drying, temperature ratings, and all of the above. So we have a little pocket in here. Not too sure what you could put in here, but you do have a pocket. And let's see, this is a little bit more manufacturer's guide, but once again, it's worn out, so you can't really read it. And there's the inside of your turnout.
Right here's your helmet. This is the outer layer, pretty solid. The inside of it, you can adjust it with this crank. This helmet meets the helmet requirements for the NFPA 1971 standards for structural fire. Here are the straps, and there's a hook to hang it up.
So here we have a wildland turnout pants. It's very different from your structural turnout pants, because this one actually only has 1 layer. As it says here, it's a fire resistant Nomex. Nomex is a anti-fire material. Let's see, it says Title 8, Article 10.1, Section 3406 for wildland fire service protective clothing. You have your cut number, your date, your size, which is a small, and your style. Let's see, right here we have the component for latching and unlatching your turnout pants. Right here you have a strap to adjust to meet your width. Turning it around, you have your straps for adjusting to meet your particular width, and you have some pockets here on the back. You can put
any tools that you would need for wildland. You have knee pads here, which are reinforced, so that's a good thing. On both knees, actually. You have your zipper here to tighten and untighten the bottom of your pants. You also have a button here to button and unbutton as well if you need to put on your boots or something like that. And that's your wildland turnout pants.
In this video, I'll be going over the parts of a ABC fire extinguisher. These fire extinguishers can be found in just about any place, in a mall or a store or even a person's house. These are good for an emergency situation where there is a small fire and an ordinary person has to take it down. It is very simple to operate this fire extinguisher, and it even has instructions on it saying what to do for in case of an emergency. The first step is hold upright, pull ring pin. Step 2, stand back 8 feet, aim at base of fire, and you should stand back approximately 8 feet or 2 meters. Squeeze lever, sweep side to side. You must sweep side to side so you get the entire base of the fire and make sure it is out. The ABC in the extinguisher stands for the classes of the fire it can take out. The Class A fire is ordinary combustibles like trash, wood, and paper. Class B fires are liquid fires such as like gasoline or alcohol. And Class C fires are electrical equipment such as computers, televisions, or anything that has electricity running through it. This fire extinguisher can take out those 3 classes of fires. This fire extinguisher holds up to 195 psi inside the tank, and how the gas is released is when you pull the lever, this blue rod goes down and releases the pressure, causing the chemicals inside to come up a tube on the inside that goes through the top and comes out the hose. The most common fire extinguisher is a water extinguisher. It is good for putting out things like burning wood, paper, cardboard, but it does not work well against electrical equipment and things like inflammable liquids, because when you add water to an electrical fire, it can travel through the water and electrocute a person that is using it. And when you try to put out a flammable liquid fire with water, it can spread the liquid around and just create the fire bigger. This yellow piece of paper indicates that it has been certified by the Fire State Marshal and that it has completed its yearly inspection, and it shows the date of in which it was inspected. It was on February 24th, 2016, and it is now a fire extinguisher that can be used whenever the time is needed, and it has to do another yearly inspection next year around the same time. The pressure gauge indicates how much pressure is needed to operate this fire extinguisher. The arrow must be pointing in the green area, indicating that it is at the right pressure. If it is under, then it needs to have more pressure inside the bottle, or else the chemicals won't come out as well. And if it is over 300 psi, then that means it is overcharged and must be inspected immediately. The operating levers is what functions the fire extinguisher. It releases the chemicals inside and allows it to open up the fire extinguisher bottle. It is released by the safety pin that is in there so it doesn't accidentally go off, and the chemicals travel through the hose and comes out the nozzle. The nozzle is held in place by this nozzle clip and is easily taken out, as you can see. And the hose is there so you can adjust where you want to aim to hit the fire. The chemicals inside is made up of CO2 and is inside the bottle, and it travels up a siphon tube assembly, and it has a discharge head at the top of the bottle.
In this next portion of the video, I will be talking about a special agent fire extinguisher. Something about the special agent fire extinguisher is that it could attack a Class K fire. Class K fire is in relation to anything that has to deal with cooking oils, animal fats, or vegetable fats. Class K is easily remembered because Class K, it starts with a K, and the cooking oils, animal fats, and vegetable fats usually have to deal with the kitchen, so K stands for kitchen. The special agent fire extinguisher is a wet chemical fire extinguisher, and it is based off of a potassium acetate. The potassium acetate based agent discharges as a fine mist which forms a soapy foam that suppresses any vapors and steam or the risk of fire reflash as it extinguishes the fire. Class K fire extinguishers can usually be found in commercial cooking areas such as restaurants and cafeterias due to the fact of the class of fire that it is used to put out. Another fire extinguisher in the fire service is a Class D fire extinguisher. Class D fire has to deal with combustible metals such as magnesium or titanium. The Class D fire extinguisher is a dry powder fire extinguisher, which is suitable for the specific combustible metal involved with the Class D fire. This particular fire extinguisher is not too commonly seen, and it is pretty hard to come by in a residential area. So this is one of the more particular and the more it is more specific to an actual apparatus as opposed to a residential area. When using a fire extinguisher, one good tip is the acronym PASS, which stands for pull the pin, hold the extinguisher with the nozzle pointing away from you, and release the locking mechanism. The second acronym, A, stands for aim low. Point the extinguisher at the base of the fire. The third acronym, which is the S, stands for squeeze the lever slowly and evenly. The last and final acronym, also S, stands for sweep the nozzle from side to side. So it is pull the pin, aim low, squeeze the lever, and sweep the nozzle from side to side. Something that I found interesting in my research was that the NFPA does not test, label, or approve of any fire extinguishers. And that is pretty odd to me because fire extinguishers are very big in not only the fire service but also in residential areas. So I just found it a little odd that the NFPA doesn't really associate itself with fire extinguishers.
We'll be going over fire behavior, and our main question is, what is a fire? A fire is a rapid chemical process that produces heat and usually light. Most people can identify fire when they see it, but few can really explain the process which takes place to produce it. Fire is characterized by the production of flame, which can be seen in many different colors, such as yellow, orange, blue, and depending on what is burning and how much heat is being produced. Fire is neither solid nor liquid, but rather a byproduct of combustible vapors being consumed during a chemical process. Fuels such as wood, liquid fuels such as gasoline, and gas fuels such as propane can all burn and create flaming combustion, which is fire. Now, we'll be going over the fire triangle. All these factors are needed to create a fire, which is oxygen, heat, and fuel. If you take one of these factors out, you can stop or disrupt the fire. Now we're going to talk about fire spread. We'll first go over conduction, which is shown in this one. Conduction is the process of transferring heat through matter by movement of kinetic energy from one particle to another. Conduction transfers energy directly from one molecule to another. Objects may vary in their ability to conduct energy. Metals generally have a greater ability to conduct heat than wood does, whereas a substance such as fiberglass has no ability to conduct heat or fire. And objects that are good conductors tend to absorb heat and conduct it through the object. So it will travel through an object. And we will go over convection now. And convection is basically a circulatory movement that occurs in gas or fluids such as air or water that vary in different temperatures, being present in the same medium owing to the variations of the subject's density. So basically, if there's a fire and someone's coming close to it, they'll be able to feel the heat that's coming off of it. And now we're going to go to radiation. And radiation is basically just the transfer of heat through energy, and it goes through invisible waves. And an example, the sun radiates energy to the earth, even though it's millions of miles away. The heat goes through waves, which you can feel. Now we're going to be going through the different classes of fire. This is a Class A fire. Class A fires always involve ordinary solid combustibles. Materials such as wood, paper, and cloth, vegetation, and brush fire is also be considered one of these materials. And easiest way to put out these fires is with water, with cool water. And with this is wood burning, and wood is a Class A combustible material. Now we're talking about Class B fires. Class B fires involve flammable or combustible liquids such as gasoline, diesel fuel, or motor oil. And these involve gases such as propane or natural gases are also Class B fires. And these fires are extinguished by shutting off the supply fuel or by using foam to remove the oxygen from the fuel. And this right here is a car on fire, mostly caused by the motor oil. Class C fires. Class C fires involve electrical equipment. Attacking Class C fires with an extinguishing agent that conducts electricity can result in injury or death to a firefighter. So it's always important to remove the power from these fires, then remove it with water. Now, this is a Class D fire. Class D fires are a little more complicated, but they involve materials such as metal such as sodium, magnesium, or titanium. And these fires are assigned to a special class because the application of water to fires involving these metals will result in violent explosion. And most of the time it can happen to computers, but this right here, these are just metal shavings. Now we're going to Class K fires. And Class K fires are very, very common in restaurants and kitchens. And these involve combustible cooking oils and fats in kitchens. Usually heating vegetables or animal fats or oils in appliances like fryers can result in these fires. And you need a Class K extinguisher to put these out. Now we're going to go through the different fire phases. And this right here is just a house on fire. Now we're gonna start with the ignition phase. The ignition phase begins with something that ignites something. It can be something small or big, and this phase typically produces an open fire. And the concentration of oxygen present at this point is about 21%, basically the same percent as the oxygen in the room. Now we're going to the growth phase. During the growth phase, additional fuel is drawn into the fire. As more fuel is ignited, the size of the fire increases. The plume of hot gases, smoke, and flame creates a convection current that carries hot gases to the ceiling of anywhere, like the room. And like flammable materials in the path of this will increase the fire, and flames can begin to start going upward and outward, and hot gases start to rise because they're lighter, and these basically hit the ceiling. Now this is the fully developed phase, which is the most dangerous phase and the most aggressive. And as the fire develops, the temperature increases, and flammable materials in the room are going through polyiosis, and gas starts to produce more. And in conditions like these, flashover is common, and flashover, the temperature in a room increases a point where every combustible material will ignite all at once. And fully developed fires are more common now because the materials that are used in houses today use synthetic materials, which are way more flammable than materials used before in the past. Now, this is the decay phase. This is the last phase of the fire. During the decay phase, open flame burning decreases, and large amount of heat just build up in the room, and it still remains hot even though the fire is out. And mostly you'll just have smoke coming out, dark smoke. Now we're going to go to different conditions that happen during a fire, and this is thermal layering. In thermal layering, tendency of gases in enclosed spaces to form in layers according to their temperature. The gases rise and they are heated and form different layers within a room. So the hotter the gases are, the lighter they become. During a fire in a closed room, gases are said to be in thermal balance where they're allowed to seek their own level. The temperatures at the floor level is relatively low compared to the hotter temperature at the ceiling level. By keeping low when there's a normal thermal balance, you stay in the area where the temperature is the lowest. During the growth phase of the fire, the hottest gases rise to the top of the room. When these gases cool, they fall and are pulled back into the fire by convection currents. When one of the gases in the mixtures reach an ignition temperature, they will ignite, and from the radiation from the flaming fire or direct contact with open flames. So, in other words, the upper layer of flammable like vapor catches on fire. This is called flashover, and basically, if the temperature continues to rise in a room where the flame over is occurring, it will get hot enough to cause a flashover. And when a flashover occurs, almost every item ignites, and it will basically just explode, and it will explode in seconds. And this is probably the most dangerous occurrence that can happen in a fire. Now we're going to backdraft. And backdraft is caused by the introduction of oxygen into an enclosed area where superheated gases and contents are already hot enough for ignition, but do not have a sufficient amount of oxygen to combust. The development of backdraft requires a unique set of conditions. When a fire generates quantities of combustible gases, these gases can become heated above their ignition temperature. And this is an interesting thing. This is called BLEVE, stands for boiling liquid expanding vapor explosions, which are very common and extremely dangerous. A BLEVE occurs when liquid fuels is stored in a vessel under pressure. If the vessel is filled with propane, for example, the bottom part of the vessel would contain liquid propane, which is under here, and the upper part of the vessel would contain vaporized propane, which is above here. And if the sealed container is subjected to heat from a fire, the pressure that builds up will expand of the liquid and prevent evaporation, causing this to explode. And we're going to go through smoke reading through a door. So when you see indications of hot fire, such as darkened windows, but little visible smoke is coming from around closed doors and from around windows, you may be dealing with a fire that's in a decay phase, which does not have significant amount of oxygen. And this is basically a great sign of danger. So when you open up a door, watch what the smoke does. If the smoke exits through the top half of the door and clean air enters through the bottom half of the opening, then the fire is probably on the same level. This phenomenon is sometimes called smoke that has found balance. The smoke rises and the opening clears out. Fresh air is being pulled into the building. This basically indicates that the fire is probably above the level of the opening. And if smoke thins when the door is open, but smoke still fills the door, the fire is probably below the level of the opening.
When talking about the fire service, one cannot forget about the wildland portion of the fire service. Wildland firefighting is extremely unique because, as opposed to municipal firefighting, which usually uses water to extract the heat from the fire tetrahedron, wildland firefighting extracts fuel from the fire tetrahedron. Extracting the fuel is done so by cutting line, and cutting line is approximately 3 to 4 feet in length all the way down to bare mineral soil. This theoretically stops the fire in its tracks because there is no fuel in the cut line to aid in the spread of the fire. There is also aerial support, and this is via aerial water tankers. These water tankers drop water in strategic areas in order to maximize efficiency. So, this was the second semester project for the William S. Hart Fire Academy, Class 16, and this particular project was done by Cadet Galvez, Cadet Haggins, as well as Cadet Beverly. Thank you.